Hello there. My name's Al, and this is lesson number 54 in this series about C++ programming. And this time, today, I'd like to take a look at a slightly more advanced concept. Maybe a little bit early for this concept, but I won't use it in an overly advanced way. And that concept is the concept of a template. Now you may have noticed that I've revived our linked list class here, and what I want to do, in fact, is change it from its previous C version, which I've been working on, to a C++ version, which addresses some of the issues that we had in the C version, the data hiding, passing the wrong types, and all that sort of thing. And in order to do that, we need templates, unfortunately. So I have to tell you a little bit about templates. Okay, well, first off, template itself is just a keyword. You notice that it turns green, therefore it's a keyword. And I don't know exactly what the help says. I'm afraid to press F1 on it. But I'll tell you what I know. I'm not going to claim to be a total expert on this. It's a thing that takes angle brackets for its parameter. And its parameter is typically a class, but it can also be a number. And I'll give you an example of one taking a number as an argument. Now, this here, so far, this doesn't mean anything. I'm going to put, let's say, size type count. Usually people like to use weirdo underscore names for these sorts of things, stuff that you probably wouldn't type in normally, so that helps to avoid name conflict. You try to make this as ugly as possible, make it horrific. This isn't bad enough, You should look at the STL and what they use. It's incredible. Already, though, still this doesn't mean anything. What this is it's something, a directive prior to declaring something else. And that something else can be a function or a class and various things. And I'm going to use, as a simple example, a function. And I'm going to make a function that returns a size t. My function, okay, and I'm going to return this count value. Now, this might seem rather strange. Why don't I just pass it in? Now, but you'll see shortly what I mean by this and why this is different than a regular type of function declaration. For one thing, this will be an error. Okay. This template specification is a modifier for the thing being defined. That is, this is not really called func. This is func that is of a type involving this number. This, for instance, would compile. And what I've now defined is a function that returns the number 5, and only the number 5. Okay, this can't change. It's in the declaration, it's in the function name. I could assert, but I'll just print it out maybe. That should print out 5. So it does. Character return. Now, here's something that you're not allowed to do in C or C++ or any language. Declare. First, let me pass something to this function, like an int. This won't compile. Now, oh, sorry. Now this won't compile because the expression here has to be constant. See? However, this in particular would compile because, as far as this thing is concerned, count here is a constant. It can only be what I've defined the function to be, 5. So this should compile, and it did. A warning because I didn't use the K or something on reference variables, but it did compile. And so what you see here is there's a way now, if you like, for whatever reason, to be able to pass a number, although it still has to be a constant number, as a kind of variable looking thing to a function, and you could create an array. That also is nothing too much to write home about. Now what I'm more interested in this particular case, let me change this to int for simplicity. If you recall, from a long time ago, we talked about this. I talked about this. I even called this a compiler bug, which I stick to that. Suppose I want to take the sum of this array. Okay, that's quite easy. For int I equals 0, I less than size of the array 3, I plus plus. Well, now I want to have an accumulator of some sort. I'll add to that. Okay, no problems. Now if I have my array of 3 here, 3 ints, I don't know, anything I could print out. The sum is %d. Now you'll notice here, see, I'm tricking you with that 3. There is no 3 there. That 3 is just ignored. It looks like there's a 3 there. Right? But in fact, that 3 has nothing to do with anything. I could put this like that, and it'll still compile, and I'll still get the same result. See? However, I made this bigger, or an arbitrary size. I don't know. Now, we don't know what the answer is supposed to be anymore. But our function will dutifully add up the first 3 anyway. And that's the same answer. But if I wanted to, I can make it go up to 50. Well, it compiles what? Fine. No problem. You see? That's probably not the right answer. Now, what would be better than this declaration would be if there was some way I could specify, without having to tell the function how big this array is, how big the array is, and let this guy figure it out. Now, what I want here, essentially, is to be able to use this count of, okay? However, this fails. It can't figure out the size of the array. And by the way, this count of, if it is Microsoft specific, you can make your own count of very easily. Num lms for an array. That's the size of the array in total divided by the size of one of its elements. Okay? Put extra brackets if it were in. That's in every sense of the word count of. But it's not going to work. It might compile this time, but it's not going to work. Sum is 5. Oh, it's obviously not 5. Remember, we did this calculation before. It always comes out 1. However, now I'm going to point something out here. This is definitely passed in by reference. Now we could make a struct and do the full copy on the stack. However, seeing that we're passing in by reference, and that is a little bit more efficient, and in this case I don't care too much about the modifying of my data, I can declare this as a reference to an array, like this. And in this case, when I specify a number here, that number actually matters. And in fact, this should not compile. It'll say that the array size is a mismatch. See? Can't convert from array of 7 to array of 3. So now by using this type of declaration, this number matters. This is actually going to give 3 now. So if I go back to my original array, there's a point behind all this, and I hope you're seeing it coming. Right? Now, how do we extend something like this, such that we don't need to specify the length of the array? We use a template. Size type count of elements, which makes this a constant value. All right, num_lms is fine. And now, no matter how many elements I put in my array, I can put negatives, whatever, it's going to compile. And it's going to do the right number. It's going to it's going to count through the right number of elements. First I'll run without going through it, stepping through it. And now I'm going to show you by pressing F8 what's going on. It has created a new function whose name is rSum of 10. That is, this is a function whose sole purpose is to count up the elements of integer arrays of size 10. It's not a parameter that I'm passing in. If I had an array of a different size, it would make another function in exactly the same code, in fact, but with a different name and a different count. This here will go through 10 times through the array, exactly the number of times, the number of elements in the actual array, and I get the sum. Now, that's pretty good. I mean, I don't know about you, but when I first figured that trick out, I was delighted. I had, no more worries about specifying the lengths of things and making sure that it's right and everything. This thing can't possibly make a mistake. It can't possibly go out of bounds. If I wanted to copy two arrays, for instance, I could do a copy of two similar types of arrays. Maybe one of them is like this, but it's a constant version. So how do I say that it's a constant ref? I guess it would be const here, maybe. Where does the const go? I'm gonna actually do. Hang on a second. I forget where the const goes. Okay, the const goes here. Right. Okay. So it's and that would mean that the elements of this array, source, let's call it, are not modifiable by this function, but the destinations are. These arrays are guaranteed to have the same number of elements, and I could say r dest I equals source of I. There's no sum, there's no return value. Now, I don't have this anymore. Let's make sure that we're okay so far. Okay, so here's an array. And I'll make another one. First one of a different size. And some random numbers. Just a second here before we go on. Right. I want the comments. I'd like it to be from 1 to 10, but whatever. Good enough. Okay. That'll be this array. Let's do that again. And that'll be this array. Maybe we can sprinkle in some minus signs here and there. Okay. 1, 2. Now, according to theory, I should be able to copy from one to the other R1's destination R2. Those are the same size. this should compile. Now you can just use this as a constant. If I wanted to, I could print that out, but let's just step over it, I guess. Here's R1, which is going to be modified, and here's R2. Okay, you can see that they're different. I hope. I wish it would print them out that way. But clearly they're not the same. That's 29 thing at the beginning, and that's different. Step over the function, and you can see these have all gone red. R1 is now, oh, I said plus equals, but you get the idea. I've added one array to another. Again, 10. Okay, so now they're the same. Now if I deleted an element from here, it won't compile. Okay, this array's too small. This one's too small. That's not really so bad, but what would be bad, definitely bad, would be if this one, if the destination was too small. Oops. No, it should not. Oh, yeah, that's another thing. Well, no, that shouldn't compile. That's the wrong size. Well, actually, it's probably going to take only this much worth of R2. Let's see what happens. No, I didn't expect that to compile, because they're not really the same size. F8. I see. See, it's doing a copy of 9. So it's only copying as much of this array that can fit into this array, which is not perfect, but it's better than crashing the system. And this problem can be fixed as well. You could use templates to make such declarations such as this conform to a particular length. Well, I could say one way to say 10 and 10, right? But that's going to work because it'll just stick on an extra empty element here, random element at the end. So that's no good either. You need to use some kind of something to do it. Template. Now the other kind of template thing, whereas instead of using a number here, you can use like a class. And often this is the name of the class is usually, or quite often, just given a single letter. And now I'm defining, instead of a function, I could be a function. Okay, could be a function. Let's make a function that takes as an argument a class of type T. Well, what can, suppose suppose it returns a T, whatever T happens to be, and it's called sum. And it takes two T's. Suppose we'll let them be constant T references. That way there's no copying involved, no copy constructors involved. Okay, and it returns the sum T1 plus T2. Okay, Now, I want to print it out. Now, luckily for us, our special string class can take almost any type through these brackets. Now the question is, will the compiler figure out which kind of sum to use here? I think it has. I think it's going to use an integer sum. This here we don't know until compile time exactly what sort of sum it's going to be. And it's chosen int, because these look like ints. Okay? And we have a streamy thing for ints we can turn those into strings. And then print them out 9. Okay. Now, what about the sum of hello? Now this one, I don't think it's going to get right, because these, I think it's just going to take as two literals, and I don't think you can even add two literals. Let's see what it comes up with. Yeah, it's not able to. It's ambiguous. Could be a car of 6, could be a car of 7. However, we can be more specific, and this may work. It should, really. Yeah. So now I'm saying, please regard the arguments as being TS strings. So now it's going to convert those to our strings, and then take the sum, and it'll come out there, which is what we expected. Now, it's too bad that I have to specify this. If one of these was a string, it might be able to figure out that since one is, they both have to be, but who knows? No, it's not. I would have to specify both of them, but no problem. But you see what I'm getting at. Here are some things with decimal points. Now this is not going to be an integer sum. It's going to be a floating point sum. So that gives us a floating point answer. Okay? Now, so we can have functions that can be declared as taking an unknown type, the type determined at the time of compile, not in the code itself. And so what this template directive stands for is essentially an outline of the algorithm you want employed, without knowing what the type is of objects that will be used in that algorithm. And the reason why I'm introducing templates here is because of this linked list. And what I want to do is, well, you'll notice from the C version, this is what we had before. Whatever this, where was the node defined? Whatever this data thing is here, the logic's essentially the same, right? So what I want to use is a template so that we can specify exactly what type of data it takes and get rid of that loss of information there, and use the same logic, but on a specified type of data, and then we won't have that problem anymore of the loss of information, data, type information, and several other things that I want to add to it. I also, before the end of this one, because this is going to be a 2 or 3 parter, let me check my time, I want to make a note that added to the string. I didn't actually add, this is not an addition to the string class. I added something which is a very useful class derived from the string class. It has like a format specifier. So, for instance, this here, I could say string f. Oops. %f. Now, string f is just a class derived from a string, so it has all the properties of a string, but its constructor takes a variable argument list. So this makes it very convenient. Look, here I've turned put s into printf, basically, right? Except for the hidden carriage return. But anything else that takes a string, any function that takes a string, I can now pretty much use that format. Every function now in the world that takes a string also now takes a variable argumentless string. So that you'll find that these things are quite useful. These format type strings, especially for a number or something like this, simple numbers that you want to be strings. Have a string. My name, and I want to do something like age is whatever, this sort of thing, then I don't have to have extra lines and things. I can just do everything in line. Just taking a number and turn it into a string. We also have these things. Whatever. There might be things missing from there. The format specifiers also have width. You can do width and precision and other kinds of things that are not normally, or not necessarily available through these defaults. Like ints here. If I use a regular int, I get this as the default. But I might want padding in here, or I might want it zeros in front if it's, or I might not want these zeros in the case of a pointer, and so on and so forth. Okay. Now, the way that all those things work, just to finish this off, and this is something you probably know from C, but if you've forgotten, the way to do variable arguments is through these sorts of functions, vs printf type functions, and what they call a VA variable argument list. Usually there's a macro called VA start, and the first parameter is actually a thing that you supply, a list. This would be maybe a better name for this. It's list. VA list. Or list. Just list on its own. Right. Maybe that looks better. This last bit actually doesn't do anything. See? It doesn't do anything. Nothing. It used to be necessary to have some cleaning up at the end of this process, but no longer. And all this thing does is it's taking this address and just trying to figure out where the next thing is on the stack. You can do that yourself almost by hand. Address of V passed in plus size of V, right? There's nothing to it. So it's taking address of this plus the size of this. And then that gives you a pointer to the next argument on the stack. And then you use these V style functions. Oops, this is not marked. Look. There are functions that take VA lists as arguments. And this is one of them. Now I called it marker again, but that's that list. VSPrintf takes a VA list, variable argument list, as a parameter instead of dot dot dot, and all this does is combining the two together. I've turned these three dots into a VA list, and I've called something that takes a VA list. That's the key to this part, and this part, and this part, and this part. Same. Okay. Now, I'll see you very shortly. I'll start on the next one pretty soon. Well, of course, there's only one person watching, so time is irrelevant. Okay, see you next time.